This tutorial explains the bounding box statistical variables. These statistical variables will be first shown using the confocal 3D Drosophila embryos image. The images are courtesy of Dominik Förster and Dr. Stefan Luschnig from the Institute of Molecular Life Sciences, University of Zurich. Imaris contour drawing mode was used to quantify cell surfaces and calculate cell elongation and orientation within the tube epithelium. The longest diagonal inside each cell is determined using measurement points. Alternatively, you can use the range of automatically calculated statistical parameters related to the bounding box. These can be found under the Statistics tab. Imaris offers two types of bounding box calculations: axis-aligned, noted as bounding box AA, and object-oriented, noted as bounding box OO. A bounding box is a rectangular cuboid in 3D or a rectangle in 2D containing a single detected object. If the bounding box is aligned with the axes of the coordinate system, it is known as an axis-aligned bounding box. The axis-aligned bounding box identifies an object by fully enclosing it within the minimal rectangular box whose local axes are aligned parallel to the coordinate system. The object-oriented bounding box identifies an object by fully enclosing it within the minimal rectangular box whose local axes are aligned the same way as the object. In this case, the bounding box is arbitrarily oriented with respect to the coordinate system. The axis-aligned bounding boxes are shown in magenta, while the object-oriented bounding box is shown in light color. The full case study related to the data used for this video tutorial can be found on our web page in the Knowledge Base section under the title Live Imaging Analysis Reveals Mechanisms Controlling Tube Size During Organ Development. If you have questions about these features mentioned here, or other features found within Imaris, please contact your local sales or support team. Thank you for watching this video.